people. Let's make some predictions. So the last two videos have had to do with simple probability, theoretical probability, experimental probability. Alright, so predictions. I'm going to give you guys 3 steps because I like to keep things easy. Step 1, write a let statement. Step 2, use your probability to set up a proportion. Step 3, cross multiply and solve. 3 easy steps. Alright, they should look familiar. Alright, so let's do 2 examples here. First example with a theoretical probability. Alright, I've got a deck of cards here, 52. It's a standard deck. Alright, oh, there's that ace. Alright, so I have a question. You select a card and put it back. Alright, that's called with replacement. Alright, so I draw 1 card. Alright, there's an 8 of clubs. I put it back. Oh, that's an 8 of spades. I haven't played cards in a while. I put it back. Alright, that's with replacement. There's still 52 cards in this deck. Alright, so you select a card and put it back. If you do this 100 times, predict how many times you will draw an ace. Alright, so this is based on theoretical probability because technically I haven't done any experiments yet. Alright, so step 1, let statement. I want to know how many times I will draw an ace. So let's let x equal number of aces. There we go, let statement. Step 2, using my probability, set up a proportion. Now, for those of you who know cards and standard decks, there are 4 aces in a standard deck of cards. That means I have 4 favorable outcomes. So my probability of an ace is 4 out of my total number of outcomes, which is 52. Alright, and we could simplify that. Alright, pretty sure 52 is divisible by 4. We can simplify that to 1/13. Alright, because I could divide my numerator and denominator by 4. So that's, I'll simplify, 1/13. It'll make life a little easier. So there's my probability of getting an ace. Step 2, using this probability, set up a proportion. Alright, so if my probability of getting an ace is 1/13, that means that this ratio should be equivalent to whatever I get after I draw it 100 times. Alright, so that 100 times goes on the right side of my proportion. This is my denominator because that's my total number of trials or my total number of outcomes. Alright, so I have 1/13 equals blank over 100. Now in that blank we'll put our x, that's our let statement, because that's our number of aces. Now, because in theory, the ratio should be the same no matter what, because this is a fair deck. So if I get 1 ace out of every 13 draws, I'll get X number of aces out of 100 draws. Alright, so we have to solve this proportion. That's step 3. Alright, easiest way to solve it, cross multiply. Alright, so I do 1 times 100, which is 100, equals 13 times x. It's 13x. There's our one-step equation. What's being done to x is being multiplied by 13, so we have to undo it. Divide both sides by 13. Divide by 13. I think we're going to get an ugly number here. 100 divided by 13. Whew, 7.69. We'll round to the nearest hundredth. So we get 7.69 equals x. Alright, I'm actually going to round up to the nearest whole. So we could expect, we could predict about 8 aces. Alright, so that's using theoretical probability. That's what should happen. Does that mean that's what's going to happen? No, absolutely not. Not unless you do about 1,000 trials or a ton of trials. Alright, so onward. Experimental probability. Remember, this is what actually does happen when you do an experiment. Alright, so you select a card and you put it back. Alright, we select that card and we put it back in the deck. Alright, so we always have 52. You draw 1 ace out of 8 tries. Alright, so we did this experiment. Alright, you drew 1 ace out of 8 tries. How many aces can you predict after 100 tries or trials? All right, steps are the same. Step 1, let statement. Let X, you don't have to always use X. We could let A equal aces. In fact, I like using let statements that remind me about what I'm looking for. So let A equal aces. Now we need to use the experimental probability in our proportion. All right, now the experimental probability, so the probability of getting an ace, is a little different. I got 1 ace, so that's my number of favorable outcomes, over total number of trials, which was 8 trials. So my probability, my experimental probability of getting an ace was 1/8. All right, so now using that probability, set up a proportion. All right, so you could think of it as like aces over total. All right, so my aces over total was 1/8 equals aces, which I don't know, all over total, which is going to be 100. All right, now I'm going to cross multiply, so I get 100 equals 8a. Divide both sides by 8. Divide by 8, and let's see, so 100 divided by 8, and we get 12.5 equals A. All right, now you can't really draw half a card, so again, I'm going to round up to the nearest whole. So we can predict about 13 aces. All right, so here in our experimental probability, based on that experiment they did where they got 1 ace out of 8 trials, we could predict about 13. In our theoretical probability, all right, where we know that the probability of getting an ace is 4 out of 52, all right, we predicted about 8 aces. All right, so see that they're not always going to be the same. Now, as I said in the last video, the more trials you do, the closer these two probabilities will become. All right, I bet if we did 1,000 trials, all right, we probably would come close to having the same prediction. Okay? All right, guys, so as always, feel free to send me any messages.